Alright, example number 3. Find the absolute maximum and absolute minimum of f of x is equal to 2x squared minus x to the power 4 on the domain x belongs to negative 4 to 3, the interval from negative 4 to 3, inclusive of those values. So we set the derivative equal to 0, find the first derivative, and factor it, common factor, and find the zeros. And we find out that the zeros are from 0, negative 1, and positive 1. So we set our intervals accordingly. Remember that this does not go from infinity to negative infinity to positive infinity, but we have hard stoppage points. So it goes from negative 4 up to negative 1, negative 1 up to 0, 0 up to 1, and 1 up to 3. So, use some test points, and we find out that the first derivative is greater than 0 in the first interval, less than 0 in the second interval, greater than 0 in the third interval, and less than 0 in the fourth interval. So we have some max and mins. So I know I need the endpoints plus the points at where the first derivative is equal to 0 and determine the values. These, what we have, are our local max and mins. Here we have our local max and mins. We need to determine the absolute max and mins. Our absolute minimum is at negative 224. Our absolute max happens at negative 1 and 1. So the values are going to be the same, 1 and 1. Those are the absolute maximum value. It happens at these values here, at negative 1 and positive 1, as well as our absolute minimum, which is the lowest number of all the values that we tested. We find out that it's f at negative 4. That's an endpoint. So that must be an absolute min. Example number 4. Determine the local extrema for the function y equals absolute of x squared minus 1 plus 2. So this is the piecewise notation for this particular example. What you see here, though, is something where you need to figure out how we got these intervals. What's important to note is in absolute function, the main thing is that absolute means that the sign changes. The sign only changes when the inside the absolute sign is negative. So, how did we get these values right here when originally we had this? Easy. This is easy by looking at what things change. In here, we're only going to have negatives when the x is either positive 1 or negative 1. So that's where the interval started. So positive 1 and negative 1 are where the interval changes. So we set our interval from negative infinity to negative 1, negative 1 to 1, and 1 to infinity. And what happens is if it's the numbers between negative infinity to negative 1, we plug in the value and we get positive and positive of this answer here. So it stays the same, plus 2. So positive of what's inside the absolute signs, we make in brackets, plus 2. And that, when we do this, we will get, when we take this and we expand this, we will get x squared plus 1. The next one, what we're going to do is between negative 1 and 1 is any number. If I plug any number between negative 1 and 1, I will get a negative number inside the absolute sign. So here is where we're going to change. We change the sign of what's inside the absolute signs, and we add 2. So here, we change the sign of what's in here. So that's why there's a negative times that, because that'll make it positive. And then we add 2. When I expand this, the equation looks like this. Negative x squared plus 3. All right, the last one. From 1 to infinity is the same as when it went from negative infinity to negative 1. So we have the same values, and when I expand it out, that will also be the same values as the original. We need to know the first derivative of each part of this piecewise function. First derivative is 2x. First derivative again of the second equation is negative 2x. And finally, the last one is just 2x. We set the derivative equal to 0. And irregardless of which one we choose, we know that from all of these, the x value must equal 0 for the derivative to equal 0. So for all of those functions. All right, knowing this, we keep going. So what is all of this? Let's step one step backwards and look at the interval chart. The interval chart goes from negative infinity to negative 1, negative 1 to 0, and 0 to 1, and 1 to infinity. You do your test points, and for the first derivative and the second derivative. The first derivative of each piece. Note that this only applies to both negative infinity to negative 1 and from 1 to infinity. The 2 inside apply to the red first derivative. You plug in the values accordingly and you find out this. There is a local min when at x equals negative 1. There's a local max at x equals 0. And there's a local min at x equals 1. So that's what I did here. Now, f at x has an absolute minimum at negative 1, 2, and 1, 2, and a local maximum at 0, 3. All right, let's go to the next one. All right, that's the end of this video, folks. Have a good day.